5 outboards, 3,000 horsepower, 1 fuel tank. That's not a thought experiment. That's an actual build sheet. The Scout 670 runs 67 feet, and Scout will hang 5 Mercury V12 600 outboards across its transom if you want them. That's 3,000 horsepower sitting behind one boat. Here's the part most buyers never get to because it's buried past the glossy stuff. Scout's own build sheet says the port and starboard gasoline fills both run into a single 1,500-gallon tank, 5 engines, 1 fuel source. That doesn't make the Scout a bad boat. Plenty of well-built boats share a tank across multiple engines, and for many failures, it won't matter at all. But it raises a question most people staring at 5 cowls across a transom never bother to ask. Are those 5 engines 5 independent backups? Or are they 5 power sources that still lean on the same handful of shared systems underneath? Picture yourself 100 miles offshore. 1 engine quits. You've still got 4. That feels like exactly the kind of margin you paid for. Now ask what happens if the problem isn't the engine. What if it's what's feeding the engine? We'll pull 1 engine out of twins, triples, quads, and 5 engine boats and see what's actually left. We'll separate engine redundancy from complete system redundancy and get home propulsion from get home performance. More outboards can make an offshore boat safer. They just don't automatically protect you from everything that number makes you assume. Before we challenge that assumption, it deserves some credit because the horsepower math behind these boats is real. Big offshore boats are heavy, and heavy boats need serious power to stay up. The Freeman 56 weighs about 44,000 pounds, ready to fish, and can be rated for as much as 2,400 horsepower. The Valhalla V55 pushes close to 50,000 pounds fully loaded, and its published configuration uses 4 Mercury V12 600s. These aren't center consoles that happen to carry extra engines. They're yacht-weight hulls moved entirely by outboards, and outboards still have a ceiling. Mercury's biggest Verado tops out at 600 horsepower. Yamaha's biggest XTO Offshore tops out at 450. So if a hull needs 1,800 horsepower, that's 3 600s, or 4 450s. Need 2,400, that's 4 600s. Rated for 3,000, now you're looking at 5. Not every engine on that transom is there as insurance. Many are there because that's what it takes to deliver the speed, load capacity, and acceleration the buyer was promised. When 1 engine goes down, the math changes depending on how many you started with. Lose 1 from a twin and half your horsepower is gone. From a triple, a third. From a quad, a quarter. From 5, 20%. On paper, more engines clearly wins that trade. But horsepower and boat speed don't move together in a straight line. Losing a quarter of your horsepower doesn't simply cost you a quarter of your speed. The remaining engines still have to move the boat's full weight, fight the hull's resistance, and carry the same total load without that engine contributing thrust. Which raises the real question, can what's left actually get the boat back on plane? Because it can still move and it can get you home through building seas are 2 different promises. People often hear the second one when a brochure is only offering the first. Start with the failure that multiple engines handle best, because this is where the whole idea earns its reputation. 1 engine develops a problem isolated to that engine. Maybe the power head, maybe the gear case, maybe a prop takes a hit. Whatever it is, it stays contained to that 1 unit. Here, the advantage is real. Every outboard has its own power head, lubrication and cooling, gear case and propeller. 1 failing doesn't automatically drag the others down with it. That's not a new idea. The Coast Guard's historical design notes say its 44-foot motor lifeboat used twin-screw propulsion partly for greater reliability and improved handling. The more engines you spread that load across, the smaller a bite any single failure takes. Go back to the 5-engine Scout. All 5 running. That's 3,000 horsepower. Lose 1 and 2,400 remains. Mathematically, that's the same total horsepower as Scout's 4-engine version. That doesn't prove the damaged boat performs like the factory 4-engine build. Prop selection, spacing, load, and sea state still shape the outcome. But it explains why a captain running well offshore might see that 5th cowl as more than an expensive extra. The same logic applies to the Grady White Canyon 456. 4 Yamaha 450s add up to 1,800 horsepower. Lose one, and 3 engines still deliver 1,350. We couldn't find a published engine out test proving exactly what that boat does at that point, but 3 running 450s give the captain options a single engine never could. That difference gets enormous when land drops out of sight. You might not be choosing between a normal trip and a slower one. You might be choosing between having propulsion and having none. Multiple engines also spread the physical hardware around. One bad gear case isn't every gear case. One damaged prop isn't every prop. One cooked powerhead isn't every powerhead. The control systems have also gotten genuinely good. Mercury's Shadow Mode lets 2 levers run anywhere from 3 to 6 engines, and Yamaha's Helmmaster EX coordinates up to 5. So no, running 4 or 5 engines isn't automatically excessive. Against one isolated failure, they can deliver exactly what an owner thinks they're buying. Another live source of propulsion when something quits. If you own a boat or offshore fishing boats are your thing, subscribe to Boat Verdict. But notice how carefully that advantage had to be described. It holds up when the failure stays isolated. The moment a problem reaches something those engines share, counting cowls stops telling you very much. The real question was never how many engines you can see. It's how many failure paths are genuinely separated. Start with fuel, because that's hiding in plain sight on the Scout. There aren't 5 independent tanks feeding those 5 engines. There's one tank carrying 1,500 gallons, with both fills plumbed into it. From there, the fuel lines, filters, and any isolation valves determine how far a problem could spread. But every one of those engines is ultimately drinking from the same source. That makes fuel quality matter more than engine count. In 2022, a commercial towing vessel, not a recreational center console, lost all propulsion after water heavily contaminated its fuel tanks and service system. Multiple engines were installed on that vessel. It still went dead in the water. The Coast Guard warned that fuel contamination isn't only a commercial problem. It can affect recreational boats too. Modern filtration helps. Yamaha describes a 10-micron fuel and water separator outside the engine, backed by additional filtration inside the outboard. That's real protection. It isn't the same as 5 independent fuel supplies, and Yamaha is blunt about the limits. No additive can remove water from contaminated fuel or restore fuel that has gone stale. What about boats running more than one tank? The Canyon 456 carries 616 gallons split across 2 308-gallon tanks, which potentially gives it more options than one giant tank. But 2 tanks don't prove 2 fully isolated systems. You'd still need to know which engines draw from which tank, how the valves are arranged, and whether both tanks could have been filled from the same contaminated source. Fuel isn't the only shared system. Every engine still needs electrical power to start, commands from the helm, and steering input. The same integration that makes Shadow Mode and Helmmaster EX easy to run also means 5 engines aren't 5 separate boats bolted to one transom. That doesn't mean one bad display or switch automatically takes out the whole installation. Manufacturers build safeguards in, and the actual protection depends on the boat. The real redundancy is buried in the fuel system layout, batteries, wiring, and whether a failed component can be isolated from the ones still working. This is where both sides of the argument can be true. A 5-engine boat can tolerate one engine going down, while also carrying more components that may eventually need attention. 5 engines means 5 power heads, 5 gear cases, and 5 cooling systems, all exposed to salt water, heat, vibration, and hours. More components create more opportunities for one to need attention. But if the boat stays usable after that happens, the complete system may still be more resilient than a simpler setup with nothing in reserve. That's the difference between engine reliability and system availability. One asks how likely a single engine is to fail. The other asks whether the boat can continue after it does. Ownership reflects the same trade. Yamaha recommends changing engine oil and lower unit oil every 100 hours or once a year, along with other maintenance at specified intervals. Mercury uses similar 100-hour and 300-hour schedules. On a twin, the engine work happens twice. On a 5-engine boat, it happens 5 times. That doesn't mean the whole boat costs 2.5 times more to run. The hull, electronics, and pumps don't multiply with engine count. But the engine side of the ledger does. The 5th engine standing by as backup is also a 5th engine you must keep ready to become that backup. Fuel economy complicates things again. More engines don't automatically burn more fuel, because hull design, gearing, load, and cruise speed all matter. But fewer, larger outboards can sometimes beat a greater number of smaller ones. Mercury published one comparison testing twin V12 600S against triple 425s. At the same cruise speed, the twins delivered 20% better fuel economy. Mercury also reported 24% better fuel economy at top speed. Both figures come from that one manufacturer comparison, not a universal rule. But they show that adding another engine isn't automatically the most efficient way to reach a given horsepower target. Which brings us to a number that's harder to find. Engine out performance. Grady White gives detailed figures for the Canyon 456 running all 4 engines. It reaches 30.1 miles an hour at optimum cruise, burning 44 gallons an hour, and tops out near 58. Scout also publishes full power figures for the 670. We could not find manufacturer-published engine-out performance figures for either of these specific boats. How fast does either boat get back on plane with one engine down? What speed can it hold when loaded the way it would be offshore? You can't answer that by dividing horsepower. The Canyon 456's tested weight is 31,650 pounds. So here's the honest question. 100 miles offshore, which setup would you trust? 5 outboards pulling from one shared tank, or fewer engines backed by more thoroughly separated fuel, electrical, and control systems. If you're a captain, owner, or mechanic who has experienced an engine-out situation, tell us what happened and why your setup worked, or didn't. And remember to subscribe to Boat Verdict.